Star Wars fans out there? And what about Star Trek? And for those of you that don't know either, yes, there's a difference.
But they do share some commonalities. Both of these famous sci-fi series use the idea of a warp drive, or a hyperdrive, in which our heroes use to travel faster than the speed of light.
Back in the 60s, this really was just far-fetched and creative. But what is the idea behind faster than light travel? And how exactly does it work?
Well, in the beginning of our study, scientists realized that massless entities, like light, were the fastest things discovered to travel through space. So, if we achieve light speed, then space exploration should be a breeze, right?
That's not entirely true. Even at the speed of light, it takes us hundreds of years for us to get anywhere. In fact, it takes us 4.3 light years to reach the neighboring star system, with the rest of the stars seeming unreachable.
Even though we've seen people create ships which travel at unbelievable speeds, even these ships can't reach the distances that we want to go. So instead of figuring out ways to travel faster, why don't we just shorten the distance altogether?
That's a great idea, but let's start with the basics. Einstein's theory of general relativity was the foundation for space, gravity, and the universe overall. According to the theory of general relativity, space-time is a four-dimensional object in which space and time are interwoven into a single continuum.
That sounds kind of confusing. So let's use an example from Earth, or how space-time works like fabric. If you place a bowling ball on a sheet of fabric, it creates a dent in which the fabric bends. So the larger the mass of the object, the larger the bend will be.
And the same concept applies to space-time. Things with greater mass, like the sun, bend space-time more than things with lesser mass, like the Earth.
So instead of trying to speed up, we just have to figure out how to bend space-time and use it to our benefit.
Exactly, and in a way, we all bend space-time. Anything on the Earth, or the universe really, that has a mass bends space-time.
Of course, us humans don't have a large enough mass to bend space-time like planets do. But it shares a connection about how we can bend space-time ourselves.
But this still isn't really useful because we're currently only observing unintentional warping of space-time, and that doesn't really help us if it's unintentional.
So in order to achieve faster than light travel, we have to figure out how to intentionally warp space-time for ourselves.
Exactly, and that's the idea behind Miguel Alcubierre's warp drive, which takes inspiration from Star Trek's warp drive. His idea was to contract space-time in front of the ship and expand it behind the ship, creating an energy density field in which the ship could travel.
In terms of the math part, his calculations fit Einstein's theories and were all feasible, with the exceptions of two things: negative energy and exotic matter.
This research was then picked up by Eric Lentz, who realized you didn't need exotic matter to build a warp drive. That left just one issue: negative energy.
Let's take a break from warp drives to help explain negative energy a bit. Negative, even though it seems like a really complicated physics term, it's not all that complex. Negative energy definitely isn't the opposite of positive energy. And to explain it, let's have a demonstration from Mr. Bjorn.
Sitting on this cart, Bjorn has a certain amount of gravitational potential energy, or the amount of energy an object holds due to its position. We'll label this as 0.
If we move Bjorn to a higher point, he would have a higher potential energy greater than 0. But if we move Bjorn to a lower point, he would have a potential energy lower than 0. It doesn't mean he has no energy. It just means he has less energy than what we decided was 0.
So when we say we need negative energy to build a warp drive, that just means we need less energy in a specific spot than the space around it. To better visualize negative energy, let's talk about boats.
Oceans have waves which carry energy. If you place two boats parallel to each other, one boat would be blocking the waves that would otherwise be hitting the other. This creates a space in between the two boats which have less waves, or less energy, than the outside of them. But how do boats relate to space?
Well, this leads to a developing idea using negative energy, Casimir cavities, or the Casimir effect, which we study to help us understand how to manipulate negative energy and space-time.
Oh, so just like our boat example, Casimir cavities take place in a space vacuum filled with energy fluctuations. Casimir cavities are the space in between two metal plates which have less energy, just like the space in between our two boats.
Exactly. And due to the heavy energy pushing against the plates, or the waves pushing against the boats, it causes them to be forced together or to attract. But why do we care about Casimir cavities?
They take us to our next step, figuring out how to utilize negative energy in order to warp space-time, just as described in the Alcubierre drive.
But we still have a lot of research ahead of us. Forget your fancy starships and come down to Earth for a moment. We barely have a grasp on most concepts. Our ideas of space-time are constantly changing with new discoveries.
That's right, we still have so much more to learn about negative energy and Casimir cavities before we can even think about building spaceships and traveling faster than the speed of light.
But still, don't get too pessimistic, because though our resources may limit us now, our imaginations will help the future of space travel flourish in the centuries to come. Look how the Wright brothers beat all odds to define the aviation industry today.
In the 1900s, a breakthrough launched us into the atmosphere. Today, we look past our solar system and into the vastness of space. Our scientific journey showcases humanity's curiosity in unraveling the mysteries of the cosmos. Thank you.